Right, and in this video we're going to be talking about graphing linear inequalities. So this is different from when we were solving them because now we're actually graphing them when they have x and y. So like when they look like they're in slope-intercept form. Right? How we go about doing that, we're going to talk about some steps first. So the first thing we need to do, if it's not already, is write the inequality in slope-intercept form. So that means if it's in standard form, we need to convert it first. If it's in slope-intercept form already, meaning it won't be the equals because it's inequality, but it'll still have that same format, y, the inequality, the slope, the x, then your y-intercept. Then we're going to graph it. And you're going to graph it just like normal. Start at your y-intercept, find your slope point, count your slope points. The differences here is that depending on the type of symbol in the inequality, we are going to either use a dashed line or a solid line. So for our less than or greater than, strictly less than, strictly greater than, we're going to use a dashed line. And if we have less than or equal to or greater than or equal to, we're going to use a solid line. So we're either going to draw a line that looks like this, or we're going to use our regular lines like that. In addition to that, we are also going to shade in on the graph. So you could do this if you're doing it on paper with a highlighter, with a pencil, lightly. When you're doing it on GoFormative, there are different colors, and you can just kind of shade it like that, which you'll see here in a bit. But if we have less than symbols, it doesn't matter if it's strictly less than or equal to. If we have either one of those, we're going to shade below the line. And if we have greater than or equal to, we're going to shade above the line. Right? So before I talked about solutions a bit. When we were graphing them, when it was just x is greater than 3, that means everything greater than 3 is a solution to that problem. But now in this case, when we shade our graph, everything in the shaded area can be a solution. So in this picture right here, all of these different points are solutions. That also includes points that are in between or that have decimals. So all of those points are solutions. The main thing with this, one, we've talked about graphing just equations. So you have to remember how to graph, remember your slope, how to find your slope, how to graph your slope correctly. But then you also need to remember these new rules, the dash, the solid, the above, the below. So we're going to start off with number 1. This is already in slope-intercept form, except it's greater than instead of an equals. I'm going to start off at -5. And then my slope is positive 1/3, so I'm going to go up 1 to the right 3, or down 1 and to the left 3, as many times as I can. So for this, I want you to fill up your graph with these slope points. Right? This does not have a line underneath it, so this is going to be a dashed line. So I can kind of cheat a little bit because I have this line. You would actually be drawing a dashed line. Right? So I have my dashed line that goes through my slope, that goes through my y-intercept. My last thing I need to do is shade it. This is a greater than. So that means I need to shade above this line. So you could color in every single square, or you could just do a general shading above. Right? Now, in this number 1, it also asks us to determine which of the following points are solutions to the given inequality. To do that, you need to see, do these fall in the shaded area or not? If they fall in the shaded area, then they're solutions. If they don't fall in the shaded area, they're not solutions. Now, I'm going to go back and I'm going to color in all of this area right here, just so we know that the parts that I missed are still shaded. I just missed them. So all of this above this line is still shaded. Okay? So the first point is 0, 0. Let me actually change this color so we can see it a little bit better. That's not really a great color either. Here we go. 0, 0 is definitely in the shaded. That is a solution. 0, negative 5. That's on the line. So let's go back and let's think about some of the things that we've talked about when solving. Excuse me. So if we have a strictly less than or a strictly greater than, the number that it's greater than or less than isn't included. So really I can say that this is more like an open circle right here. Because this is an open circle and it's not included, this should not be a solution. Right. So to see for sure if this is a solution or not, we're going to put this into the equation and solve for it. So 0, negative 5, and the equation was y is greater than 1/3 x minus 5. I'm going to put in 0, negative 5. And this is, if you aren't sure, a for sure way to see, is this a solution or is this not? So that's going back to when we were solving equations. So when I put this in, this becomes 0. 0 minus 5 is negative 5. And then we have to think about this. Negative 5 is greater than negative 5. That's not really true. If it was greater than or equal to, then I'd say yes, it's true because of the equal to. But because it's not equal to, this is not a solution. Right? Going to the next one, 3, negative 2 is in the shaded, that is a solution. 5, negative 6. That is not in the shaded, so that is not a solution. And then negative 7, 3 is definitely in the shaded area, so that is a solution. So just keep that in mind. If it's in the shaded area, it's a solution. If it happens to fall on the line, and the line is a dashed line, you may need to check it, but more than likely, it will not be a solution. Right? Let's do number 2. So it's in slope-intercept form already. My y-intercept is at negative 1. I meant that to be blue. That's okay. And then my slope is negative 2. So I can go down 2 and to the right 1, or I can go up 2 and to the left 1 from there. So up 2, left 1, as many times as possible, fill up your graph. And then down 2 and right 1, as many times as possible, fill up your graph. This is a less than or equal to. So that means this will be a solid line. Going through these points. And then shading wise, because it is less than, that will be everything below this line. And me drawing the arrows is not really necessary. You don't have to do that as well. I'm just helping you see what direction we're going to shade. So I'm not going to shade all of it. I'm just going to roughly shade this. That is everything below that line, including the small areas I missed. And then again, it asks us to determine which of the following points are solutions and which are not. So starting off with -3, 6. So that point falls outside of what would be the shaded. Remember that all of this should be shaded underneath this line. So that is not. 0, 0 is also not underneath that line. 0, -1 happens to fall on the line. Now this one, because it's equal to, everything that falls on this line should be included. But just to double check, I'm going to put this into the equation again. Let's make sure I did that right. So -1 is less than or equal to -2 times 0 minus 1. -1 is less than or equal to 0 minus 1. -1 is less than or equal to -1. This is a true statement because of that equal to. So this is a solution. -4, 0 is definitely in the shaded. 4, -3 is definitely not in the shaded. So that is not a solution. And there are others that could be in the solution and others that are not. Some of these questions will ask you to find just one. Some of them will give you some and ask you, is this one, is it not? Just pay attention to those. And we're going to do a few more. All right, so we're going to do number 3. Now this one is not in slope-intercept form. So the first thing we need to do is get it there by converting it. We have -2y is greater than -5x plus 12. We're going to divide everything by -2. So if we're remembering when we solve inequalities, if we multiply or divide by a negative, we have to switch the sign. So that's going to happen here. So our new inequality is y is less than +5/2 x minus 6. So now that it's in slope-intercept form, I can graph it. So I'm going to start at -6. And my slope is positive. I cannot go down 5 and to the left 2, so I'm going to start by going up 5 and right 2 as many times as I can. And that's all I can do. This is strictly less than, so this is going to be a dashed line. And because it's less than, I'm going to shade below. So mine's going to look something like this, except it's a little off. That looks a little bit better. And I need to shade below this line, so if you like the arrows, I'm going to go back. That would be this way, below the line. So this area right here. Right? Now in this case, it just says write one ordered pair that would be a solution. When you are writing these, I would say probably stay away from decimals, especially when you're doing it in conformative. Stay away from decimals. pick any ordered pair within the graph. So don't say like something 10, whatever. Stay within the graph. Now, if the graph is a 10, that's fine, but I think this one is an 8. 1, 2, 3, 4, 5, 6, 7. Just kidding, it's a 7. So don't go past positive or negative 7 for your x's or your y's, but anywhere in this, I'm going to pick a random point, whatever that is. 1, 2, 3, 4, 5, negative 3 would be a solution because it falls in the shaded area. Yours doesn't have to be the same as mine. It can be. Just make sure it's not on this dashed line, because any point on that dashed line would not be a solution. Right? Let's jump down to number 5. Again, this is not in slope-intercept form, so we need to solve it and get it there. Negative y is greater than or equal to negative x plus 8. Here again, I am dividing by a negative, so my sign is going to change directions. And now I'm left with positive 1x minus 8. So my y-intercept is going to be a little off the graph, and that's okay, since it's at negative 8. But my slope is positive 1x. In this case, I can't go down and left because I'm already off the graph. So for every up 1, right 1, I'm going to have a point there. And this is a less than or equal to. So this is going to be a solid line because of the equal to. But because it's less than, I'm still going to shade below. That's good enough. All right, so for my shading, I will shade down here. Oh, I didn't do the arrows again. So this would be below the line. And if I wanted to pick a random point, that would be a solution. Now, because this one is a solid line, I can choose any point that's on the line itself, or I can choose a point that's in the shaded area. Doesn't matter. I'm choosing the point that's in the shaded area, so that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, negative 6. But if I wanted to choose 7, negative 1, that would work as well. Right? The last type of inequalities you might see are our special cases. So we're just going to do 8. With the horizontal lines, it's really easy to tell the above and below because it's either above or it's below. But with the X or the vertical ones, you have to think about it. So remember your boy bucks. This is an X, so this is a vertical line at 6. I put an open circle there because this is a strictly greater than. This is going to tell me that this is a dashed line. I forgot I was on the line. And because it's greater than, this is going to be shaded above. So I need a vertical line through this point. It looks to be a little off. There we go. And then if it's above this point or above this line, I need to think greater than 6. If I shaded it to the right, would that be greater than 6? Yes, because if I shaded it to the left, that would be less than 6. So greater than 6 would be here and on. So if I were to pick a point that would be in the solution, I can't choose anything not in the shaded. I can't also choose anything where x is 6. So any x value where x is 7 would work. If we were going off the graph, we could choose anything above 7 or above 6. So I could say 10, whatever. I could say 1,000,000, whatever. So that is how we graph linear inequalities and determine the solutions. Now, I want you to practice this.